right, guys. So today we're reviewing hypothesis testing, and this is chapter 10. If you've taken stats 1 with me, then you're familiar with my hypothesis testing process that we'll be working with. And if not, you may be familiar with a similar process or you'll be learning this process. So I just want to remind you, last class, we reviewed confidence intervals, CIs, for estimating P, the population proportion. And today we're going to work on hypothesis testing to make a conclusion or describe P, the population proportion. So we're just focusing on categorical data right now. And then later on, we'll bring in numerical data, not today, later on. All right, so I'm just going to review a couple things quickly before we get into our hypothesis testing process, and then we'll look at some examples together. So the first thing I want to talk about first for hypothesis testing are the two really important things, which is my null hypothesis and my alternative hypothesis. So H naught is called the null hypothesis. This is the common view. Okay. H naught is always the equals, less than or equals, or greater than or equals. So what I want you to know is that the null hypothesis always has the equals in that part. And for HA is the new idea. The alternative view. Okay. And for my HA is always opposite of H naught. Okay, so these two are always opposite one another. So if I have an equals in my null, I have a not equals in my HA. If I have a less than or greater than in my null, then I have or a less than or equal to, I'm sorry, in my null, then I have a greater than in my HA. Or if I have the greater than or equal to, then I have the less than in my HA. So they're always opposite. And if you remember from stat 1, when we look at the HA, this is really the information we're given in the problem. And then we write that one first, and then we can write the null from the HA. We see that happen most of the time. So when I'm working in a hypothesis test, I use a 5-step process. So I use these 5 steps to complete the test. So I'm going to go through all the steps. I'm not just going to give you the steps. We're going to talk about the steps and how to do each step, and what they mean, and all of that. Okay. All right, our very first step is describing the population. So this is called the population step. Remember, it's called the population step because we're describing the entire population. This is not describing the sample. We'll do that in our sample step. So here for the population, I want you to tell me about the population. So it's tricky here because some people just want to give me information about the sample, but remember here, we need to really separate them out, and we need to be able to pull out the information that we're given and be able to tell the population. Remember, this is all people. It's not just like the 50 people we're studying, it's all of them. Okay. So here, the very first thing that we're going to talk about are the objects in the population. Okay, this is the who we are studying. Then the next thing is the variable. This is like the what is being studied. Remember, this is what's changing from individual to individual, the variable. That's what it is. Then we want to state the unknown. So what is the unknown for the population? So remember here and right now, it will be P, which is my, because it's categorical. Let me just write that here. And that's all we're going to look at right now. It would be mu if it was numerical. We don't need to write that down. We'll do that later on. And we want to define P here. So I want you to write P out in words. So P is the population proportion of, okay? So that's what I'm looking for. And then you put your context here. And that's what I'm looking for when you define it. P is the population proportion of, and then whatever we're studying, okay? It's important to define P here, and what you're using is your objects and your variables. So right above, you're using those in the definition here. You'll see in the example when we do it. And then we use this again in the goal. So it's really important for us to have this down here now, because then we just continue with it. All these steps just keep building off one another, okay? Then my last step here is goal. So if you remember, if you took stat 1 with me, each step has 4 little parts to it, okay? And some of the parts are longer than the others. So the goal here is what we're trying to prove, right? So here, we're gonna state what we want to prove, okay? And this is about the HA. Now in stat 1, if you've had me in stat 1, a lot of times I tell my stat 1 students is let's go to the next step and then we'll come back and write the goal, because the goal is our HA. So our HA is just the goal, but written in symbols. And sometimes it's easier to write something in symbols and then translate it into words. So I'll just write HA here, and we'll come back if we want to write any little notes there, we can do that. I want you to keep in mind, it's really important to write a nice goal here, because we can use that same exact goal in our conclusion statement. We could just copy and paste that wording right into the conclusion. So it's really important to write a nice goal, okay, in our stuff. And it's nice to do it early on while we're not tired of the problem, right? Because sometimes these get a little long. So let's take a look at the method step. I think I might have not really enough room. I'm gonna go to a new page because I don't think I have enough room here, and I kind of like to keep it all together. So go over here. So the method step is the second step of our 5-step process. Okay. So in our method step, you're going to define the null hypothesis. So this is not in words, this is in symbols. You're going to define the HA. I'm going to write it over here to the right because I'm going to write some stuff out. You don't have to write it to the right when you do the testing process. You can write everything vertical. That's what I tend to do. Or once in a while, if I'm trying to save space, I'll write it horizontal there. And then we want to define two other things, but let's talk about the null and the alternative, right? So we already talked about them a little bit in the very first page of the notes, but let's see what these possibly could be. So remember, when you're writing the null and the alternative, you don't want to just say, oh, it's greater than some number. Well, what is, right? It's P, the population proportion. So it's always about P. It's always about your unknown here. So in your numerical data, it will always be about mu. But since we're just studying categorical, we just write P right here, right now. So I'm going to write down the three different situations that could occur. So P could be greater than or equal to some number. P could be just equal to some number, or P could be less than or equal to some number. And then my alternative hypothesis is going to follow the same suit. And I'm just going to write it so they go right along. So remember what I said before, they're opposite one another. So here it would be P is less than some number. Now that some number is the same number between the two lines. Okay, so if it's 0.5, it's 0.5 in both of these. And remember, it would be a decimal because we're talking about proportions, right? So it shouldn't be over 1. So here I would have it's not equal to number, and P is greater than some number. Like I mentioned before, a lot of times we get our HA and our information. We write this one and then we go back and write the null, but I always write the null on top of the HA when I write them vertically. Okay. So I know like we wouldn't normally include this, but I want to just give you some extra information. I'm going to draw out the different scenarios. So if I had the top scenario, what does that look like? Or the middle one or the bottom one? What does it look like visually for us? Because so many of us are visual people, and it's just so nice to see a visual. This is nothing that you have to draw out for me. I like to draw it so you know what it looks like. And then if you want to draw this on your own piece of paper when you're working on a problem, then you can do that. So I just like to give it to you. So here, if we're going to do, let's see, the greater than. So let's look at this very top one. I'll just kind of stick to the same order. So if my null is greater than, so I'm just going to write it down here. If the null is that P is greater than or equal to some value, and the HA would be that P is less than some value, I want to know what that kind of looks like, right? It follows the HA, less than. If something's less than, that means we're looking over here in this left tail. So this is called a left tail test. And what we're studying is this area over here on the left side, okay? And remember, we're always looking at this alpha over here. Okay. Now, if we had this middle scenario where our null is, whoops, I put the cap on the wrong one. I meant to have the black out. Where our null is the equal, then that means my HA is the not equal. And when I have a not equals, the wording would be different, different than, or not equals, it might say. We'll see. In the example today, we'll see. And this is what we call our two tails, or two-tailed test for this one. And for the two-tailed test, we actually have two tails. So this is similar to like what we would look at for confidence interval, right? Where it's centered and we have these two tails. Remember, the two tails are the same value, okay? So again, here we're looking at, instead of just alpha, alpha divided by 2 and alpha divided by 2. But what we end up doing is multiplying them. So we could just still compare it to alpha. So we're consistent all the time. And then our last scenario would be here where my null is P is less than or equal to some value, and my HA is P is greater than some value. This is my right tail test. And I'm looking over here to the right, and I have this area in the right. And so what we're doing is we're comparing this to our alpha, whatever alpha may be in our situation. So this just gives you a little visual based on my HA and my null, which my null is based on my HA. So you could just say it's all based on the HA. So HA is greater than right-tailed, not equal two-tailed, less than left-tailed, okay? Now here, so you don't need to draw this for me. This is just a side note. I don't need this from you guys, okay? I need one of these, right? And it's very short, actually. It just looks like a lot. So I'm showing you all three different situations that we possibly could have. So I don't need to see a drawing from you guys. I just need to know what's my null, what's my alternative, and then the third and fourth. So down here, I'm going to say, well, we want to identify alpha. Remember what alpha is. This is my level of significance. So remember alpha most of the time, I'm just going to write this off to the side, is 5% most of the time. And sometimes we see 1% for a medical, and I'm going to say life or death situation. Sorry, I kind of scribbled that in there, but it says life or death situation. So if we're not given an alpha, we automatically go to the 5%. Or if it's a medical life or death, so maybe about heart attacks or something really serious that could be a death situation, then we would use 1%. That's if it's a guessing game, right? That's if we're not sure. You will almost always be told, especially on like an exam. Okay, I will tell you because I don't want it to be a guessing game. If it's a guessing game, it might be like on a daily, and I might just accept whichever one you give me based on the information that you have. Okay, so if you say, well, I don't think it's quite life or death, but it's medical, I'm still going to choose 1% because it's medical. I would agree with you. I wouldn't disagree. Okay, so just so you know. Then the last piece here is I want to know what curve we're on. Okay, so here you're just going to say Z curve because when we are studying categorical data, we are on the Z curve, which is the normal curve. The curve changes when we have different types of data, so it's different for numerical data. So that's why we want to mention it. So all you have to do is write Z curve every time. It doesn't change. So this is actually, looks like a long step because it takes up a lot of room. It's actually a very quick and short step once you pick out your HA. Okay, once you identify what you want for your HA, your null comes right from that. You can pick out your alpha quickly and you're always going to write Z curve. It doesn't change yet until we get to numerical data. So for categorical data, it's always this. So let me just write that. So always the Z curve for one sample categorical data, okay? All right, so that's my second step. So let's take a look at what the third step could be here. Okay, so my third step is my sample step. Now this is where we're going to report information about the sample at this point. So this one's fairly easy. I want you to actually paste your Minitab output here. So this is like a little something extra. So we're going to paste Minitab output here. Okay, so it's in the same place. We want to identify here a few things. X, which X equals a certain value, right? So this is the number of individuals that have that characteristic. We want to identify N, which is my sample size. We want to identify P hat, which is just equal to X over N, right? So it just feeds from the first two pieces that we need. And Minitab gives us all of this. So we could pull all of this from Minitab, or we might be given. So you're going to see today's example. I don't have raw data. I have summarized data. So that means I have X and I have N. So I could actually do all of these by hand. These two are just writing them out and then calculating this by hand. Or you could wait for Minitab, and Minitab gives you all of this in the output, but I'd like you to pull it out from the output and list it for me, okay? And then we're going to check for normality. Now, when we're looking at these problems, we actually have 4 requirements. I only ask you to check one, and that is the normality. So I'm going to just verbally go over the others, or maybe I'll just write them down really quick, and I'll tell you where you can find them in the typed notes, but we don't worry about the others. You may need to worry about them on the homework, but for me, you don't. So the normality check, it's the same normality check for categorical data as always. It's N times P times 1 minus P is greater than or equal to 10, right? It's always the same thing. Now, it's what P value I'm plugging in is what changes, right? Now, remember what I mentioned last week? The P value that we plug in here is the center of my curve. What do you think the center of the curve is? It's not P hat any longer. P hat is just my sample that I'm getting. My center of my curve now is actually my value from my null hypothesis. And I'm going to actually put this on the drawing, and then we have it. So the center of the curve is actually what we call P naught. So P naught is the value from H naught. So I'm just going to write it because it's for all of them. So it's P naught here. So I'm just going to write this. I'm going to use P naught. And then I'll write a little note over here. P naught is the value from my null hypothesis. So P naught is the value from the null hypothesis. So if my null hypothesis has a 0.5 up here, then that means my P naught is 0.5, and that's what I'm plugging in to my calculation. Of course, N would be my sample size. Okay. Just going to write a couple notes on this because I want to clarify with everyone. X, I'll just write over here. X equals the number of individuals with a specified characteristic. And my sample size. These are the same as before, like last class. I like to kind of mention it again in case someone forgot or they missed that. Didn't pick that up from last class. Okay, so like I said, we're going to paste our Minitab output. We're going to identify these. These are given to you in the problem. You're also given in the Minitab output. I'll show you. And then really the hard part here, and it's not even hard, is to check for normality. And remember what I want to see from you? I want to see the value you're plugging in, because this is the problem. Some people plug in P hat. That's not our normality check. It's on P naught, okay? That value from the null hypothesis. Now, I want just to mention a couple other requirements, but we don't check them. We just always assume that they're true, okay? So I'll just write them off to the side a little bit. So we have them. So other requirements. It's on page 5 of the typed notes, okay? But I'm just going to write them really quick. All our samples need to be random samples or simple random samples. So we want to make sure we have random samples. We just assume it's true. We assume that our samples are independent of one another. So independent samples. Okay, and the last one is that N is less than or equal to 5% of the population. So population size, which is capital N. So these we assume true. Okay, the only one we do not assume true is the normality, and we check that one. Okay. I just like to mention, these are on page 5 of the type notes. You can go and read about them and look at, I don't think I have too much on there. But those are the other requirements. We just always assume these are true. We don't even mention them in our write-up. We just look at the normality check. Okay. So that's my third step. My sample step is my quickest and my shortest step that we have here. And it's because everything's just given to me. It's like right in front of my face. I don't really have to think too much. This is the only thing to think about. Okay. Now, then all of a sudden, now I'm going to throw at you this, this little bit longer step, which is the result step. And it's really not too bad, the result step, when we have our Minitab output already. So of course, I'm going to go over with you like the calculations, but just keep in mind, Minitab gives you most of this information. Okay, so when we're looking at a result step, we want to know what's going on with some of these calculations. So I want to know my test statistic. And so let me just write it out here. So when we're looking at test statistic, here for categorical data, it's called the t-test statistic. And some people just abbreviate it like this, z-test-stat, and I'm fine with that. I'm going to give you the calculation, but no, Minitab gives you this number. You don't actually have to calculate it by hand in our class. I'd like to give you the calculation because I like people to see what's going on, and it means more. It gives you some meaning to that number. So Z is equal to my p hat, my sample proportion, minus the center of the curve, divided by the standard error. Now, what's funny about this is this should look just like your Z-score calculation back in like chapter 3, and it is. So my standard error, or my standard deviation of the curve here, remember what I mentioned to you last week is that whatever your center of your curve is how you check your normality and what you use for your standard error. And again, it's P naught. P naught is the center of the curve, and I use that in my calculation for standard error. Okay, so let me just write down some little information. So P hat is the sample proportion. P naught is the center, the value from the null. And of course, N is my sample size. And I just want to say it again, that this is given in Minitab. So when you copy and paste your Minitab output up here in the sample step, you will have all that information right here. It's just a number. So you're just going to say, oh, my z-test-stat is, and you'll just write what it is. I like to give you the formulas just so you have a little bit more meaning behind it. Okay, so now we need to interpret this value, what it means to us. And it seems worse than it is. It's really not that bad. All right, so interpret the z-test-stat. You can use my template, or you can just have your own statement. It doesn't matter to me. So here I'm just going to say my sample proportion is whatever my z-test-stat is. Standard errors. And I'm going to say above or below my center. I'm going to fill those in just with a different color. So right here, I'm going to use my z-test-stat. Standard errors, and then you say above or below. Remember, above means positive, below means negative. So if my test statistic, I'm actually going to use the absolute value, And if it's a positive number, I say above here. If it's negative, it's below, because now I've standardized it. I brought it down to a curve where the center is 0. So if it's positive, it just means it's to the right of the center. That's all we're talking about. And then I'm just going to fill in the center here. So I'm just going to put my P naught value. Remember the value from H naught. Okay, so you're welcome just to use that blanket statement. Sometimes I get really lazy and I'll even say my P hat instead of writing sample proportion. You can make it really short. It looks longer than it actually is. Okay, now from here we want to state the P value. So I want to state what my P value is. Remember, this is the probability. I'm going to state what that value is. Let's just make a note that P value, this right here, which one? P hat or P naught for where? Right here is P naught. Here is just P value, which stands for probability value. So P value is a probability. This one, yep, just P value. Okay. And I want you to understand that P value, since it's a probability, it will always be between 0 and 1. Okay, so make sure you understand that. A probability is always a number between 0 and 1. 0 means it will never happen, and 1 means it's absolutely certain to happen, right? So it's 0% and 100%. You can't go above 100%. So make sure when you're giving me a p-value, it's between 0 and 1. If it's not, that means you're reading the wrong value. Again, the p-value is from Minitab, okay? So there's no calculating like we had to back in Stat 1. I'm just going to make a note of this too. Given in Minitab. So Minitab's doing all the work for us. We just have to think about it a little bit, okay? And then lastly here, so 1, 2, 3, and then 4. Lastly, I want to interpret this p-value. So what makes this hard is doing the interpretations. And it's not hard because I give you the interpretations. You may use mine. But if we're not sure what they mean, then it is hard. So I want to interpret the p-value here, which is the probability. Okay, and we want to know what that means. So I'll give you my write-up, and like I said, you are welcome to use that. So if the population proportion equals the center, okay, and the center, remember, is P naught here. All right. So if the population proportion is the center, so meaning that the center of the curve is what we're thinking it is, it's P naught, there is A, and then we're going to put our P value in here. I'm going to leave it as a decimal. Probability of getting a P hat. I'm just gonna write P hat, or you can write sample proportion. Maybe I'll write that, sample proportion. Guess I didn't need to underline it, but at least as extreme as the one we got from sampling. Let's move that up. Okay, so this was the long one. What you need to understand is that when we're looking at the curve, Let me just pull up my drawings here. I'll leave this right up here too. If you're looking at the drawings, okay, and we're calculating this p-value, it's being calculated with this drawing here, okay? So let's just look at this, the left-tailed, okay? So say our HA is a less than. Then what happens is our p-value is being calculated based on p naught, my null value, being the center of the curve. So that's what all we're saying here. We're just stating like the obvious, that if the population proportion, so if P is P naught, so if it is this center, then we have a p-value probability. So that's what the probability is calculated on, that the P naught is the center, which means that's what our p-value or P population proportion would be, okay? So if that's true, then the probability would be whatever we get, right? Whatever area we get over here. It could be a small number. It could be something kind of a little bit larger. When I say larger, I mean more like a 0.4, like 40%, or I mean, you're never really going to see it greater than 50%. If you do, there's something wrong. So when we're looking at that, that's the probability. The area in the tail is the probability that we're going to get another sample proportion. So something different, another sample, not the same sample we just studied, a different sample that's at least as extreme as, so it's as far away from the center as that first one is. So if the first one's the black line, we're saying, okay, well, we have this amount of probability of getting another one that far away or further away. So that's at least as extreme as the one we got from our original sample. That's what it's saying, okay? So I like to give you that visual to go along with that one. I want to make a note that if Minitab, again, this is all given in Minitab, if the p-value equals 0.00 in Minitab, it's not 0. This is not equal to 0. It is equal to very small. If you actually took your decimal places in Minitab, you remember how you could hover over the number and click on the number? Like you could click on this and then you could right click and change the decimal places to like 16. You will see numbers there. It won't just be ongoing zeros. You will see numbers. So what I'm saying is if you see 0.00, you don't have to click on it and get the extended decimal places to see where there finally is a number. I want you just to know it's not 0. 0 means there's an absolute no chance that this was going to take place, and that just doesn't happen, right? In probability, like there's always a slight chance that something's going to take place. So instead of reporting 0 or even 0.00, we don't want to report this. We want to report very small. So when you see something like this, it just means it's very small. And what that means, it's going to be smaller than my alpha, which we didn't get to that yet, but we will. Right? That's all that means for us. So the result step is like probably one of the most important steps when it comes to all the information that you're giving the reader here. And then, like I said, all the steps build off one another. And our conclusion step is going to build off that. So our conclusion step is just our last step of our 5-step process. And for our conclusion step, I have only a couple things here. And the first thing is I'm going to ask myself, is the p-value less than or equal to my alpha? So remember, we identified what alpha is way up early in the steps. And I need to ask myself, is the p-value less than or equal to alpha? I want to see this. So if your p-value is 0.02, I want you to say 0.02 less than or equal to alpha, and then you're going to answer it yes or no, okay? So the answer could be yes. And if it's yes, so if my p-value is smaller than alpha, then we come up with a conclusion that we can reject our null hypothesis. If we answer no, so maybe our p-value is like 0, I don't know, maybe it's like 0.15, okay? And our alpha is 0.05. Then we would say, no, it's not less than. So then we cannot reject our null hypothesis, okay? So I need to see this. This is your first part. And then you're going to write a conclusion statement. And of course, I'll give you my statement and you're welcome to use it. Or if you want to write your own statement, just know there's a few pieces that I'm looking for specifically. And I'll kind of underline those and point those out. So here you're going to state what level of significance you used, what alpha. So you're going to say at the blank percent. So this is going to be my alpha as a percentage. Okay, so don't tell me 0.05%. Please tell me 5%. Okay, that's what we're talking about. That kind of like drives me crazy. You write 0.05%. So at the alpha percent level of significance, the sample either does or does not provide sufficient evidence to say that you're going to write your context is, and then whatever it is, greater than, less than, different. Your P naught. And this right here, this chunk right here is your goal. So when you write your goal up in the very first step, the population step, you could just copy and paste it. So you could say at the 5% level of significance, the sample does, if you answered yes, provide sufficient evidence, and then whatever your goal is, right? And you could just plug it right in. You don't have to rewrite it. So I'm just going to make some little notes here. So if you said yes, okay, then that means that I can reject the null, and it's all positives. Yes, I can reject the null. My sample does provide sufficient evidence. Or you would say no, right? It depends on how you're answering this. If you answer no, then you cannot reject the null. My sample does not. Okay, I just tried to color coordinate that a little bit, although I can see the green is hard to see in there. Okay. All right, guys, let's take a look at an example. I'll try to work quickly through this.
When writing PO, it's capital P, right?
No, it's P naught.
Yeah, not O, sorry, P naught. But yeah, it's a capital P, right?
It's lowercase.
Okay. So yep. If we were writing this like in our homework, we could just do a lowercase p and a lowercase o possibly to
no. So what you're going to do
the special character.
You're going to write the number. So if P
naught, right.
Yep. If P naught is this number here, you're going to write whatever that is, 0.5, 0.67, 0.75, 0.25, whatever it is, you're going to plug it in here.
All right, perfect.
If you wanted to type up P naught, if you're in Word, you could type a lowercase p and you could do a subscript. Some people just do like a lowercase p and you do a subscript 0 or an O. Mm-hmm. Or they just kind of type P with a 0 right next to it, or P with an O actually makes it look more like a subscript. All right, but it is lowercase. A capital P represents probability.
Right. Okay.
Yep. Yeah.
Thank you.
Okay. So let's take a look at an example. I'm out of paper here. So I want to take a look at example 1. which is on page 6. So I'm going to pull up the typed notes and share those with you, and then we'll kind of work through everything together here. And instead of writing it all out, I will probably just share the screen, and then you can see everything in the typed notes. Okay, so I have it pulled up here. So example 1 on page 6 says in 2008, that was a long time ago, 62% of American adults regularly volunteered their time for charity work. A researcher believes that this percentage is different today. She collects a random sample of 251 Americans and finds that 159 regularly volunteer time for charity work. The Minitab output for this test, it says that it's here, but it's not. I want to actually get it. So I really need to remove that. Okay, so when I write and show the complete testing process, remember for me, anytime you do a hypothesis test, it's the complete testing process, meaning it is all 5 steps, okay? In the typed notes, you'll see kind of like a bullet points of the testing process when you scroll through, but it's basically just everything we just did so far, okay? So I'm just gonna go down to the right here below, and I'll kind of keep scrolling back and forth. So remember the second page, the page right after the example, has a completed example, okay? And I'll keep referring back to this. So let's keep in mind, and I actually normally have a little bit more in here. Like I normally say, okay, objects. I don't know if you guys can see me typing, but I normally say objects here. And I don't leave it so blank, actually. Variable. And then my unknown and my goal. Okay, so that's how I actually like to see it. So when we're looking at the completed example, the population step, objects, variable, unknown, and goal. So the objects, remember these are everyone, this is everyone in the study. It's not just the few people that I sampled, it's everyone in the study. So the study is about all American adults. Those are my objects, all American adults. I like to see that word all in there when you're doing these problems, because then that tells me that you really get that it's everyone. It's not just the 100 people in the study, okay? The variable. So when we're looking at categorical data, I usually just write the variable as a question because I just think it's like the easy way to do it, and that's fine with me. You can write it any different way you want, as long as you get it across what the variable is. Remember, the variable is what's changing from person to person. So the question that would be asked is, do you volunteer regularly, right? And it's a yes, no question. So I always tend to do this where I write yes, no like this after the question mark, just to like kind of key the reader, like, okay, this is categorical, it's a yes, no question. So like I said here, you can write this different ways. I just typically write it as a question. My unknown, it's categorical, and the unknown is P. Now I want to define it. So P is the population proportion, or right here you'll see it says true proportion. It's just another way of saying population. So it's the population proportion. Now I'm going to use the 2 above here. So of American adults, right? Or you could even say of all American adults who voluntarily regularly, okay? And so I'm just taking the first 2 and putting them together to define P. And you always want to do that. My goal is to support my HA. Now I need to go back up and look at what it says, what it says is going on. So it says 62% of American adults regularly volunteer their time. So I'm just going to write this 0.62. And it says a researcher believes that it's different today. So if a researcher believes it's different, that's my HA. Always that new idea, right? So the researcher now thinks it's different. So if it's different, it's a not equals. I'm just writing it off to the side. So I have it so I can kind of keep going forward. So off to the side, I'm just writing HA is P is not equals, because that's what my HA is going to be. I don't know what the number is quite yet. And then my null is going to be the P is equals, just exactly opposite. So it's different today. Well, what's it different from? Well, it's different from what it said in 2008. So it's 62%. So I'm going to write the 62% as And I'm just gonna actually show you what I'm doing here. So I'm going to actually write here for my HA, it's 0.62, and my null is also 0.62. And that was at 62% that was given. And I just wrote it as a decimal, 6.62. And that's my null and my alternative. Now, my goal comes from this. So my goal is this statement, but in words, okay? So we have to go back up to the population step, and we can see how the goal is written out, or not the goal, I'm sorry, the, oops, going the wrong direction. We can see how the unknown is written out. He is the population proportion of American adults who volunteer regularly. So if you look at the HA, we said it's not equal to 62%, right? So my goal is to say the population proportion of American adults who volunteer regularly is not equal to, or you could say is different than 0.62, right? I just took what I have in symbols and I put it in words, meaning I replaced P with what I wrote for my unknown. Like you just, it all carries from one to another. Okay, so here we can see my method step, which I just wrote out and we just talked about, right? My null, my alternative. So my alternative is what was given to me in the problem, and then I had to write my null from that, meaning it was just the opposite. The numbers here are always the same, 0.62, 0.62. It didn't give me an alpha. This is not a life or death situation. We're talking about volunteering. I'm just going to choose 5%. So you can write it here 5%, or you can write 0.05. I typically stick with the decimal form since that's what we're going to use later on. And then, like I mentioned before, you always use Z curve here, okay? Because we're always studying about categorical and just doing one sample right now, okay? As we move forward in the class, we're going to move on. But right now, for one sample categorical, it's always Z curve. Okay, so you can see my Minitab output here, but I want to actually do this with you guys. So I'm going to share my screen to my Minitab screen. You're welcome to open up your own Minitab or just follow along and watch along. Okay, so when we're looking here, we're going to actually use the same steps that we used last class. So when we went to the CI, it's the same place. Okay. So, oops, let me see here. I have to eliminate this. Okay. There we go. So last class for the CI, we went to stat, basic stat, and then we chose one proportion. It's the same thing this class. The reason why it's the same thing is because it's the same calculation process. We just have to check a box saying we want them to complete the hypothesis test, which gives us more output than what we had last class. So this is the same for both operating systems. So it doesn't matter if you have a Mac, you're going to see the same thing that we're seeing right now and same steps, which is nice. Okay, so I'm going to click on one proportion. So remember here from last class, when I had one proportion, I had to tell Minitab what type of data I had. So I had to say, okay, well, I had my sample in a column or I had summarized data. Well, I don't have raw data in a column, right? I had summarized. It told me how many people out of a total number, said yes, right? So that's summarized, okay? So my number of events, those are the number of people, that's X, that said yes, and then trials is my sample size. So I have to be able to write that down or pick that out. So X was given to us and it said it was 159 people said yes, that they volunteer regularly. And we asked a total of 251 people the question. Okay. So now here we want to check this box that says perform hypothesis test. So last class we did not check that box. Now we need to. And now look what opens up, hypothesis proportion. So what that's saying is, what is your P naught? What is the center of your curve that we're calculating this on? That is my H naught. That's my null hypothesis. This is my 0.62. Remember, for my hypothesized proportion, it's a proportion. It should always be a number between 0 and 1. Okay. Remember from last class, we have to click on options here, and we want to do that. So click on options, and we need to be able to change everything. Confidence level does not matter when you're looking at hypothesis tests. So it defaults at 95. You may just leave it there. It does not matter what alpha is. People think they need to change that confidence level based on their alpha. You do not. It's different, okay? It is not that. So here I have my alternative hypothesis. Now, last class, we left it at the not equals because that was for confidence intervals. Now, this is where I need to match my HA. So if we look at our HA, it's a not equal. So again, I'm just going to leave it the way it is. But if my HA was a less than, then I would change this to a less than. If my HA was a greater than, I would change it to the greater than. Okay, so just make sure you understand this alternative hypothesis is your HA. Okay? And again, we're not in the exact, we're in the normal approximation. Okay, so
Professor, this,
yep.
Sorry, this is the captionist. Can you switch this? Thank you.
Yep, got it. So here, guys, you can see your output, and you can see that we have a lot more output than we had before. All right. Okay, so this has a lot more output. When I say a lot more, I mean like a whole nother box of output from what we had last class. Just know when you're gonna take this Minitab output, I wanna see all of this. So I prefer you to click on this drop down arrow over here on the right and copy everything and then bring it into your Word doc. So what this will tell me is that you're looking at a test for one proportion. So it tells me you're in the right Minitab function, which is important. And then look at right here, your descriptive statistics. This is everything for your sample step. Right there's your N, it's 251. You have your X, which is 159. You have your sample P, 0.633. You have everything given to you. I just like you to copy and paste it in there. And then I like you just to quickly type up. X is 159, N's 251, P hat is 0.633. Okay? And then from there, you're going to check for normality, right? In your sample step. So real quick, I'm just going to go back to our, oops, didn't mean to do that. I'm going to go back to our notes. And we could see here the Minitab output. We already saw. I'm just not addressing this last box yet, the test box. We're just going to look at this. So have we met normality? I just have a statement. Yes, we've met normality because 251, which was my N, times, now remember it's P naught. I need to see this. This is what I like to see from you guys. I like to see the numbers plugged in. 0.62, that is P naught. That's my H naught value, right? It's not the P hat, okay? I don't want to see 0.633 in there because that's not the center of my curve. And that they're all greater or equal to 10. You don't have to show me the actual number. Like you don't have to say, oh, it's 59.1, that's greater or equal to 10. You don't have to show me that. You could just show me these and I will trust that you actually calculate out and said, okay, it is greater or equal to 10. So you've met your normality. Now, say we get the case, we don't really have this in stat 1 often, but say we meet up here and it's not normal. Say you do not have a number that is greater or equal to 10. You are going to make a statement and saying that we have not met our normality requirement, but it's not going to stop you. You're going to keep going on. So you're going to keep working through the problem, and I'll just try to mention it. If I don't, maybe someone can remind me to mention it in the conclusion. So what I do is down here, I would mention the conclusion that I don't trust my results because I have not met normality. So now my results, okay? So remember the results step asks for the z-test statistic, for me to interpret it, my p-value, and then interpret that. So I want to take a look just above at the Minitab output. You don't have to keep pasting the Minitab output over and over again. Just paste it once in the sample step and then you refer back to it. So now here, I'm looking in this bottom box where it says test, okay? You can again confirm your null. It says H1, that's HA. It's just another way of them writing it. So you can confirm that you have them correctly. So it's an equals and not equals, and you have your hypothesis proportion correctly typed in. And then right here, look, it says Z value. That's my Z test statistic. So right below here, results, my Z test statistic equals 0.44. Okay, that's it. It's a very simple and quick because it's calculating it for you. You're not doing it. Then I just say my P hat is 0.44, standard errors above, because it's positive, 0.62, which is my P naught. Okay, it's just telling the location. Then it says right here, up here in my output, P value is 0.66, right? So I'm just going to report P value. That should be a lowercase p. It's just capitalized when I typed it in the Word document all by itself. So I apologize for that. P value is 0.66. And now I want to interpret that. So if the P value equals 0.62, so if the population proportion equals 0.62, there is, now whatever my P value is, 0.66, probability of getting another P hat at least as extreme as the one I got from my original sample. That's what it is, the probability. So I have a 0.66 probability of it happening again. That's a large probability. That means it's probably going to happen again. If it's probably going to happen again, what that means is that the center probably is 0.62, right? So if I have a large probability and it's probably going to happen again, then it's probably is the center is probably 0.62. It's really odd to see it greater than 50%, although with a not equal, sometimes that happens. If you had a less than or greater than, it shouldn't really be more than 0.5. All right, so I'm going to make my conclusion. I'm going to word it exactly how I wrote it out before. Is my p-value less than alpha? It's always the same question. It never changes, meaning this inequality never changes. It's always, is the p-value less than alpha? It's a yes or no, right? Is 0.66 less than 0.05? Absolutely not. It's not smaller, it's larger. Then we cannot reject the null hypothesis. Then I'm going to write my conclusion. So at the 5% level of significance, the sample does not provide sufficient evidence to say, now I'm going to type in my goal here. I'm just going to copy and paste it, that the population proportion of American adults who volunteer regularly is different than the 0.62. Okay. And that's your conclusion. So when you get to the conclusion, it shouldn't be a hard step because everything's given to you. And really the only thing you have to think about is this first part here, is your p-value less than alpha? And most of the mistakes come where people switch the inequality around. Maybe they do something to match your HA. You don't want to do that. It just is always that way. It never changes. Okay. Any questions on that test process?
I have a question. Did you get 95% from the actual question?
There is no 95%. What are you talking about?
For the confidence interval, like how do you know it's 95 or is it always?
You don't. That's what I said when I was doing it. You don't need to change that. It just defaults to 95 and it doesn't matter.
Okay, thanks.
Yes. So switch this around. So when you are looking at your mini tab and it says confidence interval, we're not worried about the confidence interval because that's not what we're studying. It doesn't matter what that is. That could say 100, it could say 99, it could say 90, it could say 80, does not matter. It has nothing to do with the test output. So it has no effect on your Z or your P value. And remember, I know your alpha is in there and your alpha is 5%, but Minitab doesn't know what your alpha is, right? You are making your own conclusions. So your confidence level there, you can just leave it as the 95, even though it doesn't, even though maybe your alpha might be 1%. You don't have to change it. It means nothing. You're not using that output here. The only time that means something is if you're looking at a confidence interval.